Hello, hello. Today we are taking a look at the Nano VNA. The Nano VNA is a very powerful tool that is very popular among amateur radio enthusiasts. It's a tool that allows you to do numerous things for both amateur radios and for other types of applications where what's called network analyzing is needed. But we're just going to talk about what you need to know for for amateur radio as a complete beginner with no experience with this device, because the instructions they're great instructions in the manual, but they're designed to cover a large variety of use cases with people who already have experience. So they can be kind of daunting and confusing when you first get into them. So we're just going to start from scratch and show you how to set it up so that you can use it to check SWR. We're going to go over what SWR is and kind of talk about briefly the other uses that it has, but we're just mainly focused on SWR today. Alright, so just first looking at the device, we've got the charging port here, we have a switch here for turning it on and off, and we've got a rocker control which can also be pushed in. And this screen is also a touch screen. We also have these two ports right here. That can be kind of confusing at first for when you're first getting into these devices, because you're going to wonder which one to use. In general, when you're measuring SWR, we're always going to use this one. We'll talk about that more later. But when you first turn it on, every time you turn it on, it resets what frequency range you're looking at. But it will save any major settings or changes that you make in there. Let's just turn down the brightness a bit so you can see the screen well. So the first thing we're going to want to do whenever we're using this is choose what frequency range that we're going to use, and then we're going to have to calibrate it. So calibration, basically the Nano VNA has a very, very wide range of frequencies that it can look at and analyze within an antenna. The upside of that is that it can be used, it's fairly affordable, and it can be used for VHF, UHF, HF, even some of the Wi-Fi stuff, and shortwave. It can be used for all of it. The downside is that it requires calibration in order for it to be accurate within whatever range you're looking at. So for today, we're going to look at using it for a HF antenna, but it's identical for calibrating it for a VHF or UHF antenna or any frequency. You just first are going to either tap the menu on here or press this button to open up the menu. And we're going to go into stimulus. And stimulus is where you're going to set the frequency that you're looking at. It's what's going to be displayed as the start and the stop on here. It's kind of, think of it as zooming in on the whole wide range of frequencies. So we're going to do the start, and this is for HF, so let's just start at 1 megahertz and stop at, let's do 50 megahertz. So that's most of the HF bands. We'll do that. Let me actually just zoom in so you can see exactly what I'm doing here. So I want to start. You can type in whatever you want, 50, in this case M for megahertz, and then stop right here. Oh, sorry, I did it backwards. Stop is 50 megahertz. The start is 1 megahertz. So you can see at the bottom it says our start is at 1 megahertz, our stop is at 50 megahertz. So now we're going to calibrate it, and you're going to want to do this every time that you change what frequency you're working in. So, for instance, if you only use it for VHF and UHF, you can probably calibrate it once and leave it for a while, although I do recommend calibrating if you change environments and stuff like that that are significant. It depends on the user. I mostly just kind of leave it because I'm using it for a simple range. In your kit that you get, you're going to have a few different tools that you can use. This is all for calibration. You're going to have actually two of these, but we only need one. This is just a simple SMA connection. That's what these take, is SMA. We have also these three little bits right here. These are little calibration bits. Now the first one that we're going to look at is load. Let me just explain how this works quickly. So whenever you have an antenna, the center is load, or the center is not load. The center is the signal that you're actually going to be transmitting. The outside part is the shield and also acts as ground, and that keeps it from getting interference as it's being, going through. So in this situation right here, this is attached to a resistor, so it's got a resistor between the ground and the signal in the center. So when we attach it, it's going through a resistor. That's simulating a load of an antenna or something like that. The next one we're going to look at is an open circuit, and this one right here, if you look in there, it looks like there's just nothing in the center there. There's no center signal core. That's because it's just got the ground for you to screw onto. It's got nothing attached to the core, so it is an open circuit. There's no connection. The last one we're going to look at is short. So it looks the same kind of as the load one, but if you look closely, you'll notice that it's all made of the same material. it's all connected. So if you went with a multimeter and checked the center bit right there and then the ground on the outside, it's all connected. And this simulates it being shorted together, the two sections being connected into a short. So now what we're going to do is we're going to open up the calibration menu. We're already focused in on the frequency we want to use today. So we're going to open up the menu by either tapping on the screen or pressing that rocker. And we're going to go, we're still in the stimulus menu. So we're going to go back into calibrate. We're going to reset it. You're going to want to do that every time that you're recalibrating it. And we're going to go into the calibration menu. And it's going to walk you through all the steps, basically. It has all the options right here. The only thing that we're not going to do on here is isolation, ISOLN. And let's zoom back in so you can see what's going on screen. We're going to start with open. And remember, open is this one that has no centerpiece. So we're going to screw this in, press open, and we'll see a little blue bar go across the top as it does it. Yep, there we go. That's it for that part. It's having short highlighted now. It wants us to do that, so we're going to go and grab the one that's just one piece. It shorts it. If I can manage to screw it on there. You can see the screen's going crazy in the background. We're going to do short. That's done. We're going to put it through that resistor in the load. Remember, we're not doing isolation. We're just going to skip right over to through, which is going to be attaching this loop cable to each end. We're going to go over to through. Well, now that we've done open, short, load, and through, just attach that. Now, there's two options here. There's done and there's done in RAM. Done will save this calibration even when you turn it off, and done in RAM will just save it in this active, like, we'll save it to the RAM basically. So when you turn it off, it resets to whatever calibration you had previously saved. This is great if you're just really quickly using it on HF and you normally use it on VHF, or vice versa, or you're using it in a different environment than you normally use it, and you want to have it still saving that calibration you have for back at home. But for now, we're just going to do done. We'll let it in save slot 0. Alright, so now that it's calibrated, let's look at the actual screen itself. This is ready to use, but we have a lot of information on here. And by default, you'll notice I have SWR. That's not even going to be showing when you first get it. In order to get SWR to show, we're going to go into display settings. Display settings are where you set what's, well, on the display. Pretty straightforward, I suppose. We're going to go into trace. And you have up to 4 traces. There's trace 0, trace 1, trace 2, trace 3. It's 4 total. And each one of those gets its own color of like text and stuff. For this environment, we're just going to be using the SWR meter. So we're actually going to turn off trace 2 and trace 1. And we have trace 0 selected, which means that that's the trace that we are going to be changing settings for in the previous menu. You're going to go into Format up here. This is where you choose what exactly it displays. In this case, SWR is already selected. If not, you'd click on that. There's also a little more options in here that you can use, but we're just really interested in SWR. We go back, and we'll just click here to exit the menu. So, now that we have, I see it's lost focus here, so let's just turn that back down. Now that we have this set up here, it's ready to display SWR. Now there's nothing connected, so it's got pretty bad SWR, understandably. You see the little infinity symbol there. So what we're going to do, we're going to attach it to this here, which goes to a ball-in that goes to an antenna. Actually, first, let's talk about what SWR is. SWR, standing wave ratio. It's the measurement of how much signal is reflected back into the radio that it's transmitting out. Ideally, you want pretty much none, and that's going to be a 1 SWR. 1.0 is the best that you can get. Whenever it is reflecting back into the radio, it's power that's not going to the antenna and it's not being transmitted, and it can also damage the radio. Anything up below 3 is technically safe to use, but it's not really ideal for the radio. It's not ideal for your signal, so we definitely want it at least below 3. So now we're going to just attach this adapter here that allows us to connect to this PL259 cable. These do not come with the Nano VNA, so you might need to get those separate. They're like $10 for a 2-pack. And we're going to plug this right in here. And you can see it's showing these dips on here. Now those are dips in SWR, and we can use this rocker to move our little, see this little number 1 right there, that's our like little selection bit, and as we move to the right, it moves it to the right, and we can go to the left as well. Now, once it's up high enough, it goes off the screen, so it's hard to see, but we can see that we are currently selected at 24 megahertz, and the SWR dips down to about 1.9 right there, if you can see that, which is not bad. Keep on going over to, oh, there it is. Now it's in there, and we'll move it over a bit more, and now we're at 18.15 megahertz, and it's at 1.7. And yeah, that's the basic idea of it. I usually have, what is it on as well? I usually have the, I have the second trace on as well. I set that to log mag, and that's not really anything you need to pay attention to, but the reason I have it like that is because I can actually see the marker on there even when it's got a very high SWR, so I know where the marker is. You can see they're both in the same place, but that way you can kind of follow it and stuff. But yeah, so as we're moving this around, it moves around where it's looking on there. So what's great about this is that if you are, say, tuning it for, we'll say, 28 megahertz, 10 meter range. This also works for CB, of course. We'll see that this dip is too low, right? Now, normally, if you're making a normal antenna that's tuned for one frequency, there would only be kind of one major dip. But this would mean that we need to shorten the antenna because it's tuned for an area that's a bit lower than it, right? That means that, the wavelength that it's good for is a bit wider of a wavelength. So by shortening it by an inch or so, we'll see that go up a little bit. So this is a great tool because it can show you not only whether you have to, whether it's good, but it'll also show you whether the antenna is too long or too short. And if you, once you get a hang for it, you can kind of have an idea of how much you have to shorten or lengthen it by. And yeah, that's the basic idea of this. There's other use cases for it as well. You can connect each end of a feed line to this, so this would be the transmit end, and you could eventually have it come back to here to receive to figure out what the loss is. I've never done that before. It's possible. Maybe I'll do a follow-up video later on talking about how to do that. Yeah, that's the basic idea. So the only thing left to show you now is just how to actually use this with a computer, which can make it a bit easier to track results and see it just on a bigger screen. So let's transition over to that. First, I'll just show you how you plug it in. It takes a USB-C cable. Same type of cable that a lot of Android phones use now. And once I can find my cable, we're just going to go ahead and plug that in, which so far I cannot. So we'll just grab this one right here, which is actually just a charging cable, but you can see we just kind of plug it in right on there. And it should connect to the computer right away with no additional drivers needed or anything like that. And we'll go over and look at how that's used now. Alright, so now we're back on our computer here. We've got the Nano VNA connected over USB-C, and that Nano VNA is turned on and connected to an antenna. You're going to go to, if you don't have the software for it yet, you're going to go to nanovna.com, over to Nano VNA Saver, and then they have a link to the GitHub page where it's an open source software, which is good for security and bug fixes and stuff. We've got the download links over here. So depending on what system you have, if you have Windows, just, whether you have a 64-bit or a 32-bit system, and then you can also do it for Mac or Linux. Downloading and running it might be different if you're doing a Mac or a Linux system, but once you have it downloaded and set up, it should be pretty much identical. Now, I already have the software downloaded here, so we're just going to run it. It's portable, which means there's no actual installation required if you're doing it on Windows. You can just run the file wherever. It does save settings locally in your computer. Even if you move the file, the settings will go with it because it's stored in your app data folder. So we're just going to open this up. And right off the bat, just like how the display was set up a bit differently than how we wanted it for the Nano VNA on the actual screen of the device, we're going to need to change some settings here for it to look nice. We're going to go to display setup here, and I had changed probably polar plot over to be SWR. The rest are fine. They're just nice little things to share with people if you're working with some great experts and you have some questions or something. I prefer dark mode. We're going to show lines that will plot between the dots of measurement that it has, so that way you have a better, easier to see spot. We're going to also add some VSWR markers. VSWR, it's just SWR. I don't remember what the difference is between VSWR and SWR, but for the purpose of measurements, it's the same thing. You'll see it say VSWR, and that's SWR. But we're going to add 1.5. Anything below that is pretty great. Ideally, 1.0 even, but we're going to add 2.0. We're going to add 3. Anything above 3 is just could be damaging to the radio and stuff, just something you want to avoid. Alright, so we've got all of our settings done on here. Let's make the line a bit thicker, actually. Line's even thicker than that. We're going to show marker numbers. Alright, and all these settings should be pretty much good to go. When you first have it connected, it's going to check all of your COM ports, which is just the way that it interfaces with the computer. I'm going to find all the ones that are Nano VNAs. So in this case, there's just one connected, so it makes it easy. Connect to device. And it's already showing a live display of what it last saw on there. It's going to, whereas previously you'll have seen that the Nano VNA was automatically refreshing every 3 seconds or so. This is a single sweep mode on the computer. So every time you want to change something or want to take another measurement, you just do sweep again. We can also go into sweep settings and do continuous sweep, and that will keep on refreshing it as we go. So this is the graph that shows SWR. It's very similar to the graph that was on there, although it has a wider range that it will look at. So we were only seeing probably, I think, below about like here on the Nano VNA. We have a much better picture of exactly what's going on in the computer, which is nice. You have 3 different points to work with. These are shown up here, like little markers. So you can select them one at a time, and you can kind of click on these low points and see, oh, this is, this dip right here is at 12.27 megahertz, and it's got an SWR of 1.7. You can also enter in a measurement on here yourself. So we could do, we have to stop sweeping though, because it it likes to deselect it when it's sweeping. We will do 20 meters. Let's do that for a start, which is just going to be 14 megahertz, and it's going to go to the nearest point there that's measured. And that's over there, and at 40 meters we can see that the SWR is 6, which is not good enough to connect directly to the radio, but with a tuner it's not terrible. This particular antenna, I plan on shortening it, so all of this shifts over to the right a bit. Anyways, yeah, so these points you can use to reference, if you're looking at just one band, you could have to be at the bottom, the middle, and the top of the band to have an idea of exactly what's going on. It also shows the impedance. How that works is going to be beyond the scope of this video, but you want it around 50. Tuner can help you with that. But yes, okay. So overall, we've got the VSWR, we've got the return loss here as well, which is just the return. It doesn't have the power calculated into it. And we've got pretty much all the information we need right here. If you want to share it with someone, you've got the option to take a screenshot. Just the standard Windows key plus Shift plus S will let you copy a screenshot of your choosing to your clipboard. You can also export these as files that you can load in the software later on and share that with people too. And another useful tool if you're comparing antennas or comparing changes, you can set a reference. So you can set the current display as reference. See, there's now kind of like 2 lines. It's the same antenna, of course, so it looks pretty similar. But it shows that in the background, and as you change things, you can kind of see the old and the new right next to each other, which can be really great for comparing antennas or setups. All different types of use cases there. Oh, to zoom, scroll key. You can't zoom out though, so you have to reset it. I don't know if there's a bug or if I'm just missing a key, but yeah. And that's pretty much it. That's pretty much all you got to know about this. Some of the little notes about the software here is that you can also calibrate it on here after you've selected the start and stop of the sweep. And then just a little note that the wider of a sweep you do, the less points there are within each area. So see, if you see these little dots here, let's just reset the reference. Actually, the dots aren't really displayed, but for the sake of that, let's make the line thinner. Yeah, see these dots here? These are individual measurements, and it's just kind of averaging between them. So there could, for instance, be some random dip here between this dot and this dot, these 2 measurements. I mean, there isn't in this case, but it's just worth noting that the larger range you take, it's still taking the same kind of number of measurements along the way, and that's shown up in here. This is taking 490 kilohertz steps, so it's taking a measurement every 490 kilohertz. So if we do a sweep, for example, from 1 megahertz to 3 megahertz, you can see the same number of dots, but it's just a very zoomed in area, and it's a lot more specific to that area. Again, you'd want to recalibrate it, although I think it's fine because it's within our original range of calibration from 1 to 50 megahertz. I've not noticed an issue with it, but yeah, basically you can use these settings to tune it however you want in order to read it, and just have a great tool to measure things. You don't need a transmitter behind the Nano VNA, it creates its own signal, and it's just very accurate, very quantifiable numbers that are, you know, unparalleled to other SWR meters in my opinion. So yeah, that's the Nano VNA. I'll have some links in the description where you can get them on Amazon. They're not affiliates. I'm not making any money off of this. This is just because I like to share this with people. I recommend getting the Nano VNA, at least with firmware version 3, because it can have a wider range that it can look at. And it's also great to get some PL259 to SMA adapters. Again, that will be in the description. And maybe some B and C adapters, depending on what type of connections you use. You know, look at what your antenna takes or what your radio takes, and you're going to want to get adapters for that, just so you can quickly and easily measure all those things. And that's pretty much it. Thanks for watching. Leave a like if you want. Feel free to share this video with people that might want to learn more about the Nano VNA, and I will see you on the radio waves.